Hi everyone, this is me Saima Khadim from Daud University of Engineering and Technology, Sindh, Pakistan. Well, today's my paper presentation topic is Smart Cognitive Cellular Network. These are the contents of my presentation. Why we use cognitive radio? According to Cisco Visual Networking Index, the global IP traffic will reach 168 exabytes per month by 2019, and the number of devices will be 3 times the global population as per United Nations estimates. The world population is 7.5 billion as of May 2017. Due to extensive use of bandwidth-hungry applications such as multimedia applications, the bandwidth cannot be provided by classic static frequency allocation schemes. Additionally, new challenges shall also be incorporated by the radios for minimizing energy consumption as well as optimization of wireless resources. Cognitive radio provides a viable solution to resolve above issues, especially spectrum scarcity, through a secondary use of white spaces. Here we can see two figures, figure 1 and figure 2. In figure 1, mobile frequencies are getting crowded, while other frequencies are unused or free. In figure 2, we can use the whole spectrum band with cognitive radio. Introduction. Cognitive radio was first introduced by Joseph Medolla and Gerald Q. McGeough in 1999 for a flexible spectrum access. Cognitive radio is an intelligent wireless system that can observe in its environment and can dynamically adjust their operating parameters so that it can adapt to improve the communication capacity and quality. Cognitive radio is composed of two types of users, the primary user and the secondary user. Learning cognitive radio for best resource management, it starts by sensing the environment and analyze and then make decision for dynamic resource allocation. Literature review. These are the papers which I have read. Channel status prediction for cognitive radio network, and their authors are Vamsi Krishna, Temiliro Pingwang, and Dusit Nyato, which is published in 2010. In this paper, the author used two techniques, multilayer perceptron and hidden Markov model for spectrum prediction. The benefit of channel prediction is that it does not require any prior knowledge of the channel, and also author compared the accuracy of multilayer perceptron and hidden Markov model. Next one is artificial neural network based spectrum recognition in cognitive radio, and their authors are Rahul Singh and Sarita Kansal, which is published in 2016. The motive of this paper is to increase the decision accuracy below various noisy conditions and is implemented by using multi-layer perceptron neural network, upgrade the throughput using three types of neural network: perceptron neural network, feed-forward neural network, and Elman neural network. An author concluded from the results that the perceptron neural network is slightly better than feed-forward neural network and Elman neural network. Next one is comparing performance of MLP and RBF neural network for TV ideal channel prediction in cognitive radio, and the authors are James Winston, Fuller Thomas, and William Okello, which is published in 2013. In this paper, the author compared the two algorithms, that is multilayer perceptron and radial basis function. Neural network, the mean square value of MLP is 0.0666 and the RBF is 0.0835026. So MLP is slightly better than RBF. Next one is channel status prediction cognitive radio network using neural network Levenberg Mark-coded algorithm. And the authors are Pavitra Roy and Dr. Muralidhar, which is published in 2015. In this paper, the author used neural network Levenberg Mark-coded algorithm for channel prediction. The ideal slots prediction is based on past information, which is also based on sensing history. The CR select ideal slot for data transmission. Next one is Constructual Neural Network Based Spectrum Prediction for Cognitive Radio, and their authors are Masij Jolanta Mazira, which is published in 2015. In this paper, the author used conceptual sigma-if neural network to predict the status of channel for cognitive radio, and from the simulation results, It observed that the contextual sigma if neural network improved the efficiency of channel status and also it reduced the sensing time for channel status prediction. Next one is a neural network based spectrum prediction scheme for cognitive radio, and the authors are Vamsi Krishna, Timulio, Ping Wang, and Dusit Nyato, which is published in 2010. In this paper, the author used TV white spaces, ultra high frequency and very high frequency band for spectrum prediction by using MLP algorithm, which increases the accuracy and reduces the sensing energy. Next paper is learning based primary user activity prediction cognitive radio networks for efficient dynamic spectrum access. And the authors are Anirudh Agarwal, Shivangi Dubey, Muhammad Asif Khan, Rajan Gangopade, and Sumitra Deban, which is published in 2010. In this paper, author provide longest ideal time slot to the secondary user, prediction of ideal time slot by using machine learning technique, that is artificial neural network and support vector machine. Next paper is performance evaluation of neural network based spectrum sensing in cognitive radio, and the authors are Rahul Singh, Sarita Kansal, which is published in 2016. In this paper, the author used neural network for the prediction of spectrum in the presence of noise in the environment. Neural network is intelligent which is used to predict the unused spectrum by adjusting the operating parameters with the capabilities as per the requirement of secondary user. Methodology. As static allocation is being used worldwide, the use of spectrum does not rapidly. Cognitive radio spectrum management includes analysis and decision making of whether to keep the resources for primary user or to allocate it secondary user without creating any interference to primary user. The efficient resource allocation is vital for the cellular system of next generation of networks. The decision of resource allocation should be very fast and highly accurate, otherwise issues regarding quality of service, interference and system reliability arises. We use combination of two methods, spectrum sensing and spectrum prediction by using machine learning to make the system more accurate and cost effective. By real-time spectrum sensing, we have created a dataset for a cellular, and for further accuracy, we will predict the created dataset by using machine learning techniques to get most accurate and the best available spectrum holes for secondary users in very less time and cost. Different time slots with certain duration can be analyzed. Figure 1 shows the spectrum sensing in 1800 MHz. Noticeable change in amplitude can be observed. Figure 2 shows the spectrum sensing of 1800 and 1900 MHz. Figure 3 shows the spectrum sensing in 2100 MHz band. In figure 2, in figure 2, in figure 2 there is a variation in amplitude between 1.8 GHz to 1.86 GHz, while from 1.86 to onward amplitude is constant. These spectrum holes can be used by secondary user for transmission. We can use this information to train neural network to predict the available spectrum holes instead of sensing the spectrum again and again or sequentially move from one frequency to another. The frequency slot which is available for a small fraction of time should be avoided because it will greatly impact on the performance of the radio. If any slot found free for a maximum time, it will be assigned to secondary user. Also, if primary user will return back to their band, it will become occupied. Now secondary user required to find a new slot. In such of new slot consumes large amount of energy and also time, which can causes interference between primary and secondary user and also turns on the effect of the quality of service. So created a data set by spectrum sensing at a different times in a day. To make a data set more accurate, spectrum sensing is performed 3 times of an each band. Then the created data set is trained with the artificial neural network. From the data set, artificial neural network predict the slots which are less occupied with the primary user. If a slots are required with less occupancy and also having maximum idle time will be selected. When cognitive radio needs a slot, instead of sensing the entire band, it will directly reaches the slot which is available and has maximum idle time. The slot which is selected for a maximum time, secondary user can continue communication for a maximum duration. This method will increase quality of service and also reduce interference. Create a dataset for a cellular network by using a USRP device. Conclusion. By artificial intelligence, major issues can be solved, reduce sensing time and interference between primary and secondary user, increases quality of service as well as system accuracy. Decision of resource allocation is very fast and highly accurate. We have implemented this method in cellular band due to spectrum scarcity problem. Implementation of this method will be more convenient as the secondary user will be operating in cellular band only. It can be implemented easily in most other frequency bands as well. These are the reference of my paper. Thank you.